Hey everyone, we're doing another arithmetic sequence, mathematical induction, to show that the given statement is true for all natural numbers. It's arithmetic because our common difference here is 3, and you see the 3 right here. That's going to help us when we add the next term. So we're going to check for condition 1, and that is when n is 1. Then it should equal 2, our first term. So I'm going to plug in 1 here, get 1/2 times 1 times 3 times 1 plus 1. And that's going to be 1/2 times 3 plus 1 is 4, which equals 2. So that checks. Now for condition 2, use an if-then statement. If this statement is true for some k, like our k being, say, 1. So we're going to go ahead and write this with a k. Whoops. Then it should equal that. So if it's true for some natural k, then it should be also true for the next natural number, k plus 1, which is basically the next term. So I'm going to write this sequence down again. 2 plus 5 plus 8 plus ... plus 3k minus 1. And I'm going to use my little trick to find the next term. So the next term, since my common difference is 3, this is like arithmetic sequences are linear, I'm just going to add the 3 to this y-intercept portion of it. So that's going to write the 3k, so it would be 3k plus 2. And the next one would be what? 3k plus 5, because you keep adding 3. So it'd be we have 3k plus 2. What would the next one be? 3k plus 5. So I'm adding 3. Next one would be 3k plus 8, and so forth. So that's just a trick to make life easier. All right. So now this equals 1/2. We already know that the next term with k is k plus 1. And I'm going to do the same thing to this piece. I'm just going to add 3 to this. So the next term is going to be 3k. You copy him down. And 1 plus 3 is 4. So we want the left side to look like the right side. And I know that this portion here equals my sum here. So I'm going to copy him down, my sum, and use substitution. And then I'm going to add this next term we have, and it should equal this side over here. Now what I notice is I have a 1/2 on the outside here, and so I'm going to keep my 1/2 on the outside here, but if you notice, this 1/2 does not include this portion. So basically you either use the common denominators, which I did in the previous video, but all I'm going to do, I'm going to start taking shortcuts now because this is number 7. I want this guy to join in here with this so it can look like this side. And all I'm going to do is multiply him by the 2. So it's going to be 1/2, and in order for him to join, for this to make sense, it's going to be plus 2 times 3k plus 2. Alright, it's the same thing as getting the common denominator, and it's a lot easier once you get used to that. Alright, now I'm going to simplify him inside here. You get 3k squared plus k plus 6k plus 4, and this is going to give you 1/2 3k squared plus 7k plus 4. Now we have to factor this, but we already know it's supposed to look like this, right? So I'm going to go ahead and just make it look like that and then check. So make it look like k plus 1 times 3k plus 4. Or if you want, what you could do is FOIL this out. If you FOIL this part out, you get 3k squared plus 4k plus 3k plus 4, which gives you 3k squared plus 7k plus 4. And then you can match it up that way. So either way, the left side should look like the right side. So we have proven condition 1 and condition 2. Therefore, the given statement is true for all natural numbers n. All right. This means we have, which is what had to be proven. Thank you and have a nice day. Bye-bye.